Welcome back as we continue our wonderful journey in core mathematics. My name is Nanaya Wedu, and you can call me Senana. Remember to like this video, share this video, comment at the comment section, click on the notification bell, and especially subscribe to my YouTube channel so that you can get all videos on time. In our previous lesson, we've looked at a type of vector which is an equal vector. And in this lesson, we want to continue and look at other types of vectors. So consider other types of vectors. Now let's consider what a zero vector is. So basically when we consider a zero vector, it is also known as a null vector. So zero is also null. So basically when you have a Cartesian plane, imagine that we have a vector that is just beginning at a point and ending at a point. Then that is what we call a zero vector, right? So with a zero vector, the magnitude of the vector cannot be anything but zero. So the magnitude of a zero vector is 0. But then because it doesn't have any length, it will not have any direction, right? So the direction of a zero vector is undefined. So here we see a zero vector here, right, in relation to a normal vector that has its magnitude and its direction, which we find here. And then we also have another type of vector, which is called a unit vector, right? So when we consider a Cartesian plane, if you have a vector that moves from the origin 0 and 0 towards probably the 1 on the x and 1 on the y, then we see that we have a unit vector. So this is a unit vector, right? So if this is A to B, right, this will represent a unit vector. So basically a type of unit vector can be a vector that has the x coordinate as 1 and y coordinate as 1. So the length or the magnitude of a unit vector should be 1. So for instance, with this vector, square root of 1 squared plus 1 squared should be equal to the square root of 1, which is equal to 1. So the magnitude is 1. Now, if you have any vector at all, we say that we can convert that vector into a unit vector by considering the vector. For instance, if the vector is v, we divide it by the magnitude, and then that gives us the unit vector, right, u. So we represent the unit vector by u with a heart symbol, right? Now let's consider how we can find a unit vector or make a unit vector. So for instance, let's say we have a point or a vector a which is equal to 3 and 4. So 3 means that 3 on the x-axis and 4 on the y-axis, right? So we know that to make a vector a unit vector, so we can call it u hat, which is a unit vector. It is the vector and the magnitude of the vector, right? So it means that how do we find the magnitude of the vector? We must square the first part, so 3 squared plus 4 squared. So this implies that our magnitude should be equal to the square root of 16 plus 9, right? 4 squared gives us 16, 3 squared gives us 9. So the magnitude is equal to the square root of 25, right? It could also as well could have brought the 9 first before the 16. We know that addition is commutative. So our magnitude is equal to 5 units, right? So our unit vector u should be equal to 3 and then 4, which is our vector, all divided by the magnitude, which is 5. And we can rewrite this as the unit vector to be equal to 3 and 4. Because division is not possible with vectors, we will multiply by 1 over 5. Because this means that we have 3 and 4 divided by 5, where we can rewrite this as 3 and 4. 3 as a vector on the top, right? It's not division, right? And then 4 down, right? When we change this, it will multiply by 1 over 5. So once a scalar multiplies a vector, it will multiply the top and the down. So u becomes equal to 3 multiplied by 1 over 5, and then 4 multiplied by 1 over 5, right? So it means that our unit vector is equal to 3 over 5 and 4 over 5. And we can test this. We can be able to check whether the unit vector here is indeed a unit vector, because we know that for a unit vector, when we find the magnitude of the unit vector, right? So when we find the magnitude of the unit vector, so magnitude of u, we should be able to get 1. So 3 over 5 all squared plus 4 over 5 all squared. This will give us 9 over 25 for this side, and then plus 16 over 25. And that implies that we'll get the top part to be 25 all over 25. So it means that our square root of 1, 25 over 25 should give us 1, should be equal to 1. So we've been able to show that once we have a vector, when we divide it by the magnitude, we should get a unit vector. So this is something you'll be doing when you are moving forward in the area of physics. So you have to go through so that it helps you. Now, our last type of vector will be our position vector. So basically, we've looked at position all the time. And basically, we are looking at the location of a vector with respect to a reference point. So for instance, like the origin. So where we have the origin here, 0, 0, right? And then we are moving to a place, let's say A, which is here. The position of the vector just looks at the reference point and then looks at where it ends. So basically, from the origin O to a point P, then we have the position vector. So in this lesson, we have basically looked at some other types of vectors. We've considered the zero vector. We have looked at the unit vector, and we'll be able to determine how we can make any type of vector a unit vector. And then we've considered the position vector. In our next lesson, we want to consider how we can perform some operations on vectors. So addition, subtraction, and then multiplication by a scalar. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.